Okay, you're on. What do you got?
1 second. I need to look over my homework again. I hadn't got a chance to look at it by class on Thursday, so I just wanted to come in. Yeah, so I'm pretty sure you explained this on Thursday, but I wanted to, like I said, I hadn't got a chance to look at it. So the for the first one, it's Bruce's modeling exercise. That's the one. Is that the one? Just so I'm clear, where we went into MATLAB and then we did like one by one.
Yeah, I mean, I didn't actually go into MATLAB. I showed you the results of that.
Okay.
Yeah, there are slides associated with that, but yeah, it's fit the first sinusoid and subtract off the error after you do that, then fit the next sinusoid of a different frequency and so on.
Okay.
Okay, yeah, that's what I mean by that.
Okay. And then you said you'd posted a video for number 2. I haven't got a chance to look at that, so I don't want to ask a question before that.
Did I?
Oh, sorry. I thought maybe I interpreted that wrong.
No, it wasn't. It would no. Well, it didn't really apply to number 2. So.
Oh, I said it might help with assignment too. Okay. Okay.
Yeah, and it might not.
Okay.
It'll come up later, but looking at assignment 2, maybe a little bit on the first part, but probably not that much. It's just, it's about periodic signals and their properties. So yeah, maybe not. Maybe that's not particularly helpful yet, but it will be.
I think I just want to read through it over again, just to make sure I don't have any other questions. But I think that the first one is really the main one.
Okay.
When you ask to plot the histograms on the same plot, is that like two different, like two subplots on the same figure, or do you want them on like the same plot, different colors?
So usually same plot, different colors, but they could be subplots. The key thing is make sure they both have the same, like x-axis scale,
Right.
so that you can compare them visually.
Okay.
That's the idea. If they, if they don't quite have the same scale and if they aren't made the same, then the visual comparison isn't meaningful.
Right.
Right. And that's the whole point of making graphs, really, is so you can make visual comparisons.
Yep. Also, can I share my screen?
I can make it so you can. Hang on. Okay. Okay, you should be able to share now.
Okay. I was just wondering, so this is supposed to be the filter for this, and it seems like it has more data points. I guess no, it doesn't because the X scale is the same. But is I guess like part of the question is like why is the Y scale different if it's just a filtered version?
Okay, well, this is the filtered version, right? Oh, I'm sorry, you can't see my pointer. The one on the right is the filtered version of the one on the left,
Right.
right? Well, the filter has changed the amplitude of some of those spikes.
Oh, okay. Yeah, that makes sense.
Yeah. I mean,
Yeah.
filters take away stuff, right?
Right.
So that's not a surprise.
Okay. I think that's all I really had. Thank you.
Okay. All right. We can move on. Next.
Hi, sorry, I'm eating, so it's gonna come out a little jumbly.
Okay. Let me go back to here.
Same question with number 1. I just want to make sure my graph looks okay.
Oh, well, here, let me. Okay, let's see. Yeah. Okay, you can share.
Okay, perfect. Oop, okay, here you go. Okay, so this is the MATLAB code from the resources itself. And so all I did is I took the FFT of the TB and I plotted against the Y with the absolute value. And is this normal?
Yep, looks normal.
Okay.
But, when we look at graphs, we have to think about scales, right? So you might be missing some important details.
Like the labels in the title, or are you talking about looking at it from 0 to 15?
Yeah, I mean like your y-axis scale, right? You can see, because you can see a little peak there, right? Oh, now it's gone.
Yeah, so I can see one here.
Yeah.
Let me see if I can.
There are ways you might be able to see those better.
This one?
Yeah, and the others.
Oh, I can adjust I can just set the y-axis, just set the axis manually.
Exactly.
Okay.
Or you could make it a semi-log. So a lot of times like power spectral graphs, people will use semi-log because that reveals, important details. And it's really just a question of using the scale that shows what you need to show. So, if we kind of step back and say, okay, that high value at frequency 0, what is that? What does it mean?
That's the initial response without anything, right?
Well, no, because this is a frequency graph, right? So frequency 0 is what? What sinusoid is that associated with? The sinusoid of 0 frequency.
Are you asking about sine cosine curves?
Well, yeah, in a sense, but zero frequency accounts.
Would that be that would be like a phase?
No, there's no phase at 0 frequency because it accounts for the average value.
Okay.
Right? Because if you kind of step back and think about it, all the sinusoids basically go positive and negative, but they, basically vary about zero, right? All the sines and cosines,
Right.
right?
But usually, like when the frequency's at 0, that would mean like you have like a sine curve.
Yeah, except it's not a sine curve. It's just a constant value.
Mm-hmm.
Okay. Because if we want to, if we want to build this signal of all these sinusoids, the only thing that gets us to, away from zero is the DC, what some people would call the DC term. Basically,
Okay.
the part that's the average value that doesn't change over the whole, recording period of the signal, right? We might call it the baseline. That
Mm-hmm.
the rest of the signal varies around. So all of the sinus, all of the frequencies from 1 and up all represent things that we can build out of sinusoids, but all of those sinusoids, go from plus or minus 1 and vary around 0. And so the only way to get something that lifts that whole signal away from 0, and this is a temperature signal, so it's like got an average value, I don't remember what it was, like 40 or something like that, is to account for the DC term, the zero frequency term.
Okay.
Okay. Now, after I've explained all that, I'm going to tell you we generally don't care about the zero frequency term. Okay. And so that's another justification for saying, oh, you know what? When we plot this in MATLAB, it scales it according to the highest value. And often the highest value is the zero frequency term, but the zero frequency term doesn't matter to us. Okay.
Okay. So we can just set the y-axis to the part that really does matter, which would be like this part.
Exactly.
Okay.
That's the point that I'm making. So you can either do that with, a linear scale and, using an appropriate linear scale, and yeah, the DC term will go off the end. So what, right? We don't care. Or you can use a semi-log scale.
Okay.
Okay.
Okay. Perfect. That was the only question I had because that's as far as I got during TAing. While I was TAing. I will email you with more questions when I come across it.
Okay.
Thank you so much.
Yeah. Bye.
Bye.